Hi, my name's Bob Grinier and I'm a volunteer with the Martin Fleischmann Memorial Project. So welcome this 14th of April 2024 for O-Day, Tornado. So how is everyone? Can you hear me out there? All across the world I can see we've got a good quorum here. Hi Vanilla Isis, Creating Awareness, Tony Yavoni, Rennie van der Wood, Mark Alexander, Kelly McRaven. I'd be very happy to see you too, Kelly. Josh S, Tony, Anne Witkowski, Estonias, Alex Del Castillo, Joseph Collar, Lithnick, wow, D2105K, Gaia Zyme, Nick Knock, Tucker Tries, Corky Goss is in the house, and we've got Malcolm Bendel as from Altholt. We have Mark Alexander, Nick Moore, Bo Sinclair, me myself. Hi Artifact there in Germany. Hi Lucas. Hi Gordon Doherty. I hope it's not too late for you. Simeon Hine. Per Nicola Haukland. Matthew Reynolds. Martin Hughes. David Stadbauer. Joe Velacci. Yes, we have quite a quorum here in the house. PJ Mike. Nathan Bartenshaw. Hermes Tristan. Come on, try Mysticus or try Megisticus. Gary Johnson and Tammy and Ken Pratt. Wonderful. Right. So what you're looking at on the screen there took me a couple of hours to do with the assistance of Adobe AI today in Photoshop. And I wanted to capture the kind of rough and ready sort of vortex nature that you have on the outside of the Bin Juin Huang yin yang apple structures and the kind of tornadic structure that you get in actual tornadoes, kind of something similar there, and the tearing of the ground. I hope it captured it for everyone. Now, of course, via correlation with John Hutchison samples and observations in Suhas Raukar's ultrasonic system between 2017 and 2018, I came to the conclusion that something in these systems was creating the ability for electrons to not behave how they would ordinarily behave. And so you could get matter slipping past matter almost as if the other matter wasn't there. Like it removes the normal interaction of electrons, and therefore you could say charge interaction in the ordinary way, and therefore things like friction don't manifest in the way that they ordinarily do. And if you look at the kind of, we've got a 6 here, if I switch to this frame here, we've got a 6, this part of it, and we've got a 9 here, all the way down here. We've got this 9 coming down. And I like this 9 because it captured the same kind of feel that we see on this waterspout tornado on the, well, just off the Florida Keys here, taken by NOAA in 1969, which we've referred to a number of times in the past. Yes, there's no, I'm not showing myself. I am here. It's not just a recording of me. Don't panic. And yeah, so when Chris sent me or reminded me of the wind hex, we looked into the wind hex and we showed videos of tornadoes turning metal to dust, and also everyone's seen those videos where you, for instance, I think in America they had these 36 wheelers and the metal sort of freight compartment was, or cargo compartment, was being lifted up in the air and then gently laid down. We've referred to these in the past. And you know, if you imagine it was extremely fast wind, you would imagine it just going, you know, spiraling around at that, but it just gently comes up and it gently gets put down. And so something very weird is going on with tornadoes. And we thought that we might have an opportunity to employ them with the wind hex, which I believe will start really performing when we get high temperature and moisture in there. Moisture, obviously water is a polar molecule, so it's kind of charge separated by default. And when you spin things around, you get this charge separation going on, particularly if you have a hydrophilic material like metal in play. And I think that we will get some very good results out of that in due course, as and when time permits the particular researcher and researchers involved to move forward with that. But this isn't the only thing that struck me recently. There was a presentation last week, in fact this week rather, and I felt I really needed to do a translation of it into English, and the reason being is that it really looked like it was creating a toroidal moment, and with all that comes with that. And so I asked a couple of questions of Sergei Godin, who I know reasonably well, and he was kind enough to answer them. For those that haven't seen that, I will play that now. So essentially it was inspired by a CERL device, and it has these rollers here, and you imagine if you spin a metal roller around very, very quickly, you'll get a kind of, what is it, a monopolar generator, something like that. But he talks about these things when I ask him the question, and I'll just let him talk now. In the later slides, I don't know which one it is, but you have this bidirectional magnetic flux going through the magnetic rollers.
This one?
Yes, that one. You've got that fixated on the nodes. Are you suggesting, firstly, that the flux loops occur at each nodal point?
This is roughly what I think. I don't know exactly what was happening there, but it shows here like an energy transport. This is a magnetic wall that a certain substance moves along, and it brings energy to the rollers.
Okay, and then if that is creating a magnetic flux loop per magnet, is that not then creating the donut-like shaped structure that would create a toroidal moment?
It's hard for one to imagine such a structure forming in the air, so a substance is needed here. Such substance has been described by Bishkov. That is some charged ether that can move without experiencing friction through ordinary neutral matter. Therefore, I assume that this very etheric substance is formed here, and it forms some toroids, closed toroids, exactly like this.
Okay, thank you.
In general, we found it complicated, but the idea itself seemed very interesting. Why? Because at that time, I was interested in thinking about how tornadoes work, and then this structure seemed very much like a tornado. That is, some whirls are formed. That spin is powered by heat. It concerns the environment and basically generates some additional mechanical energy by lifting objects into the air, moving them, and so on.
Okay, so it was weird because I translated that, but I was only looking for the bits where 11 Labs got the dubbing translation wrong, chopping those out and reworking them and manually fixing where there was obvious words like rabbits was rollers was replaced a number of times with the word rabbits, and so I had to fix that. I missed one, I think. But anyway, it was only when I was listening back to the premiere of that I heard him talk about the fact that he was inspired by the original description of the Searle device, of which his device, the MEC, is a patentable and was patented in Russia and the US derivative. And as far as I understand it, I think it's basically out of patent now, which is interesting. He described the fact that what he was seeing there kind of had all the signatures of something that might be similar to what is going on in driving a tornado, and, you know, talking about the kind of essentially propulsion type or seemingly anti-gravity or mass reduction type processes that can go on. And of course we know other weird things, and we're going to look at some of those weird things today. So here we have another supposed energy system that is bending what one would consider the laws of physics that we all abide by, you know, because you cannot break the laws of physics, Jim. But apparently tornadoes do, and it inspired Frank Polivka, and we know it seems to be doing weird things with the observations of those systems. And Sergei Godin considered that the Searle device was exhibiting these same things. Now, it's interesting that it was on the standing wave nodes where these so-called magnetic walls were being created. And he actually shows a vortex spiral coming out and going in on both sides. What he doesn't show is that structure, if it was projected in, you know, a 3D type structure. And essentially what that would look like is rings. And of course the rings have got rings in them, and you can imagine that those rings have got rings in them. And so you're getting a fractal toroidal structure. And in one part of the presentation, he talks about another author that replicated his type of device, and they saw very large temperature reductions, like not 6 to 8 degrees like they have experienced in their device in 1993 in their tests that they did. But he was experiencing room temperature down to minus 10 degrees. That is a really big shift. And he was curious to think that's why such a small device could create such a big effect. I haven't done the geometry overlay, but what I would hazard to guess is that the reason it did that is because its proportions were more in line with what nature wants to do, and the system wasn't fighting the less than desirable arrangement of the rollers and overall system. So I suspect that the geometry or the magnet alignment was such that it was much closer to the sacred geometry, and this means that potentially those that wish to develop this analogues of this technology that in my mind is I think it's basically out of patent now, and I think that's why the people in Shenzhen were able to do it, but they were asking for Sergei's assistance, and you know, I think he's been working over there with them. So I think with this understanding, there could be a potential to have much more success with those kind of devices. I'm not suggesting people go rush out and do that, but you know, just having a large temperature differential in itself is you can get a thermoelectric generator to produce electricity like from that alone. So that's really rather interesting to me. Okay, so what else? I did a previous presentation referring to a paper, Micro Tornadoes by Matsumoto. And one of the early replicators of the Ultra experiment was Thomas Kaminsky, and he made some videos. And in one of his videos, I clocked this apple-like structure with a bright spot in the center and a tornadic column coming down from this overall structure. And given the fact that we know this is cavitation in water, this certainly fitted the bill for the overall thing that you might expect. Obviously, the samples which I got, the magnetic particle, had a vortex-like structure to it. But it was the comparison between Lyon's reactor, that is Neil Crichton Gould's reactor, and that which was in the paper of Takaaki Matsumoto that interested me the most when I came across Takaaki Matsumoto's work in this area. Of course, I'd already published the Lyon work in October of 2018 in my Seek and Share presentation in Sochi. I'm just going to bring up the paper so that you can see that. I have it here somewhere, I think. All going well. Or not. As the case may be. Maybe I don't. Let's just see if I put it somewhere. Whether my machine is going to come to a standstill. I thought I set it up so that it wouldn't today, but maybe I'll get unlucky. Well, okay, so here we go. I will post the links as ever in the blog. So, this was proceedings of the autumn meeting of the Japanese Atomic Energy Society in the Niigata Institute of Technology, and it was in 1999. Discovery of micro-tornadoes, micro-ball lightning, which was generated and controlled during underwater spark discharges, was discovered by the nuclear collapse reaction during its transport through wires. Since small whirlwinds can be generated by the rotation of wind, it was ordinarily considered that large-scale tornadoes could also be similarly made. However, tornadoes have such high rotational energy, they cannot be explained by such a fluid-based origin, and the cause has still not been clarified. Lightning strikes could give us a clue, though. Here, intense electrical discharges could generate large itonic clusters. This is his understanding of what ball lightning is, enabling electrical nuclear collapse. The itonic clusters, read ball lightning, which would be generated during underwater spark discharges in the laboratory, could be very stable and can fly freely underwater or in air. This is what we observed in Suhas Ralkar's lab in 2017. They did not care about other things in the fluid of the ultrasonic fluid, ultrasonically treated fluid. They would move where they wanted to move. It seemed to be similar to the curious, shining, naturally occurring body of ball lightning. Therefore, it is called microball lightning. Microball lightning could be self-compressed by the strong force of the itonic cluster, inducing nuclear reactions inside. Also, because microball lightning is negatively charged, it is attracted to the anode and can transport through wire lead called the second electrical current. So he rediscovered cold electricity, in my view, which had already been deployed in various technologies in Russia during the Cold War. In this report, underwater spark discharges experiments. Anyway, so this is the image he shared, and this in fact is the image that you will find at the back of Steps to the Discovery of Electronuclear Collapse. I think it's actually on the last page, or second to last page. There we go. It's on page 288, there down the bottom. It's actually better in this paper, and however, almost this time last year, I was capturing videos, and I found from him that he took this image right here using screen grabs of video frames and patching them together. I think there might have been a couple of patches put together to produce this image. So in the video set that I captured, which I'm going to remaster in a better way this next trip going to Japan, because I've got better equipment I'm going to bring with me. I captured it, but in this time I captured it in color. So if we go back to our presentation here, and I had the honor to meet him briefly with my translator Sho. Thank you very much, Sho. And here is the good man himself, looking in his own way like Tesla did in his very crafted photo promoting the weapon to end all wars. And the image that I composited a few hours before I went to see him to show that his work had been replicated, I chose, a couple of subjects to share with him, and one was the multiple replication of his micro tornadoes. Obviously, his one, which I remastered in color, and that is this. This is on copper. And you can see our ball at the end. And notice this connection here. Notice this particular shape of the connection to the ball. And notice the linear channels, okay? And then these substructures which going at an angle, okay? So it's going at an angle, 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 so on. Okay? This here, when I saw it in black and white, reminded me of what I had seen in January 2018, shared in January 2018, and was part of the initial 1/3 of O-Day presented in Sochi in Russia. And that was in a reactor, the first reactor that was run by Lion in June 2017. And this is fused quartz. And as people know, fused quartz is really quite a hard thing. And it has done exactly what you see in Matsumoto's work. It's cutting in here, and there's another one cutting in here. I imagine that there was two structures going around and cutting, and they were out of phase with the travel in this direction. So you've got linear cuts this way, and you got transverse cuts here, but they were interspersed. Okay? Going back to Matsumoto's, similar kind of thing going on. You've got a cut here, then a cut there, then a cut here, then a cut there, right? Okay? This is in copper. It doesn't care what the material is, it will do the damage. This is in fused quartz. In 2018, this is in 1999, this is in 2018. In 2020, Dr. Alexander Parkhomov, fellow of the Russian Academy of Sciences, observed this in materials associated with his low-energy nuclear reaction experiments, principally with nickel and hydrogen, a Piantelli type reaction, but with the Russian-made carbonyl nickel PNKO2. And this is in the second hardest material known to man, which is boron nitride. Boron nitride. And you can see we have the linear scrapes here, okay? Just like we see in the Binjuin Huang crash, one of the more recent ones that I showed you. And we have these transverse ones, okay? The transverse ones. And this is an optical image of the overall structure, and this is the scanning electron microscope. So somehow it is cleanly cutting boron nitride, one of the second hardest materials known to man, after diamond, that is. Okay? Now, we've seen many spiral things, and we've seen many things that are similar to this ball at the front. And in fact, in one of the second panels that I shared with him, I showed this image here from the analysis of the Vega Valley of Henk Urian. And this is on brass rather, this is on fused quartz, and this is almost essentially exactly the same as that in a different example on copper with Dr. Takaaki Matsumoto's at 1 point cold fusion. This mark, and this is on aluminium in the supernova reactor. And so these are classic marks, but I wanted to show him the 1-for-1 correlation and scale with some of the marks that he had observed. So in his process, he's got HHO, he's got plasma balls, and of course he's got extreme hydrodynamic shear and cavitation going on. All of those things are present, okay? All of those things are present. In Dr. Roy Shinomaz's, we clearly showed we had cavitation. This is from the Indian foil that I placed in there. It was 75 microns thick, and it was placed in the 179 hertz vibration system, which we showed produced ultrasound, and it showed it produced cavitation spots on the steel vibrator plates and on the palladium coated vibrator plates. And here you can see the same kind of pattern here that we saw in the Caduceus structure that we shared from Bin-Juan Huang's system. And this looks like it's being lifted up, and this looks like it's being rammed into the surface. Lifted up, rammed into the surface. So you can see the overall rotational moment going on, and you can also see that it has a hard kind of cutoff down here where the main action is occurring. A hard kind of cutoff. Unfortunately, I didn't see in this one a ball. Maybe there was a ball and it was somewhere here, or maybe it's buried in here, or maybe it's shot off. I don't know. But we did see balls in other cavitation system by, and I'm not showing you, am I? This is very depressing for you. There we go. It's not changed. There we go. Sorry. Did you see this one? Yeah, did you see this one? Tell me if you saw this one. When did I stop showing you? Right, you saw this one, Lithinik. Okay, good, okay. Okay, so just to go back, this is the copper, this is the ball at the end. This is the fused quartz, and these are the patterns going through. And this is in boron nitride with these same kind of linear traces coming down and the transverse cuts into the second hardest material known to man. Here is the impact of a structure, in my view, synthesizing a range of elements here on indium foil in Dr. Roy Shinomaz's vibration system. And this bit is lifted up, and this is punched into the surface. This is twisted over. This has a vortical type nature to it, very similar, in my view, to what we observed in Bin-Juan Huang's system recently. And there's a whole bunch of synthesized material in here. Like I say, I didn't find, or actually at the time, I wasn't really looking for an iron-rich crenellated sphere. And I'm talking about the fact that the most of the damage here is cut off at a particular distance. Now, in another cavitation system, very simple, ultra experiment, Alan Goldwater, I challenged him. I said, go away, get some aluminium foil, run it for as long as you can. He ran it for 900 seconds. And, you know, run a magnet round like David Buttier did first, and see if the products are iron-rich crenellated spheres, and indeed they were. And on the outside, you get silicon dioxide, and that was that. Compare that to this from the indium foil exposed to a Mars vibrator plate, and you can see we have silicon here, we have potassium, we have aluminium, we have magnesium, and lots of carbon and oxygen. So these are some of the stellar synthesis elements. The indium is obviously in the material to begin with, and cesium was in the added to the liquid in there. Okay. Now, another example where we had very, very clear signatures of these effects was in the Vega Valley. And this is the Vega Valley operating here, and it's producing coherent matter in the form of fluidized electrons in this crack between the two brass plates, and that is bleeding between those two halves. This is actually the underside of the two plates that were placed on top. It's not the Vega Valley you've all seen many times. This is actually kind of like the reflection of that. And the fluidized electrons bled out as a magnetic fluid and produced these kind of like woodworm-like patterns. Well, as part of the analysis and presentation of the Vega Valley, I used an Urugo 400 times lens with a Samsung Galaxy S7 12 megapixel camera, and I took this video, which I will play for you now. These effectively are showing where the micro ball lightning, the kind that was observed, in my view, by Takaaki Matsumoto, are coming out from the central channel, this central channel here. And what we're actually looking at is the single plate, which is the actual Vega Valley itself. And it's fluidizing instantaneously, and then almost instantaneously, as soon as it's moved away from fluidizing the material, it's solidifying, and it's leaving these tracks. The grey stuff here is predominantly zinc oxide and copper oxide, but predominantly zinc oxide. And so it's eating through the zinc oxide and into the brass below and churning it round like a blender, almost instantaneously. And I believe that this is the kind of tornadic effect. And we've seen this at extremely beautiful res under the SEM. And it has this hard cutoff. Now, when I play this, you'll see a lot of this. So let me play that for you now. Hi, Bob Greenyer here, volunteer with the Martin Fleischmann Memorial Project. Again, you can see the strong demarcation down the bottom there between what looks like normal brass and what is almost certainly some type of copper oxide structures. So these are the channels where the fluidized electrons went. These are some of the marks of potentially synthesized materials. These are the kernels. We find that inside the kernels they have these toroidal substructures. Okay, I'm going to skip on to where we are looking at the effects on the brass of the ball lightning. So we're coming up to the sort of outer edge, and here's a start one. One's bled out here, and it's starting to manipulate cut through the oxide and manipulate the brass. I imagine that if there is going to be transmutations, there would be on boundary areas where you're not getting exactly the same effect, bulk effect. This is more interesting than some other areas. And cut straight to the chase. So this is bleeding out from the central channel. Little micro channels that are bored into the plate. They're kind of like fanning out, dancing around, and so on. And actually, if you go over this area, it's quite extensive, this area. Very nice, very nice. Look at it. And over here, you can imagine that these ones, where there's some separation, it might have been that they bounced between the upper plate and this plate and produced these channels, or came in from the side there, you can see. Now, if we zoom into this, you'll see. Very interesting. Very interesting. Can you imagine if this was any ordinary particle, the energy it would take to do that amount of manipulation of brass? So I'd be very interested to see if there's any unusual or unexpected elements in these plasmoid, potentially coherent matter tracks that we're seeing here. Look at it. Sometimes it looks very copper-like, sometimes it's very brassy. Okay, so you can go and look at that video on YouTube yourself. Now, in the same kind of area, we saw a breakup of ball lightning, and the key products, not all of the products, but the key products that were observed is near to the iron, just like you saw near to the iron in the ultra experiment of Alan Goldwater in his Magic Sound lab. You had silicon dioxide, and then outside of that you have calcium oxide, okay? Then in between you have all the magnesium and so forth elements. Looking closely in here, we saw the signature iron-rich crenellated sphere with the carbon-rich accretion disk coming around the equator. Now, I did show another one, and I am totally amazed. Now I'm starting to really have a picture in my mind about how these things act. Things just look so obvious. I wasn't sure when I saw this before. I took an image just in case because it looked like another separate ball lightning and it seemed to have these things going on. But now when I look at it, it is just perfect. It's perfect breakup. I mean, not quite as perfect the one I've just showed you, but it tells another part of the story. And we have this in 8,000 by 8,000 pixels, okay? So first I'm going to show you a quick image and go over it, and then we're going to go into Photoshop and we're going to look around it. Okay, so here it is. Boom, right? So what we have here is one that's come in here and it's crashed at this point. We've got a circular kind of impact point here and a little bit of spread here. It then came up here, and is it breaking up? I don't know, but we've got a Caduceus here. We have a Caduceus, and we're going to look at this in more detail. And literally, as the other symbol of a Caduceus is, you have this kind of circular bit here, which is the radius of the large crenellated sphere which we have over here. Just like Matsumoto showed here. A kind of Caduceus. This is the Caduceus. This is the top half circle of the Caduceus, and this would be where the sphere is. This is what we've got here. The Caduceus coming up here, then we have this half circle, and that radius there is essentially the radius down here. Okay? These are all of the different materials. You can see another little bit breaking out here. You can see another sphere here, another little sphere here, another little sphere here. So I'm going to be looking at this in 8K. What do I mean about the other representation of the Caduceus? Let me just go and look for that. For people that don't know what I'm blathering on about, it might be helpful to actually get that. And it's just another case of they knew how to symbolize the Caduceus. And it's on the ancient coinage. It's the simplification of it. Where is it? Where is it? Where is it? Where is it? Oh, I'll try a symbol. They're all doing the winged snakes. Yeah, they're all doing the winged snakes, not the Caduceus that's on coinage. Okay, well, maybe I'll put that into the blog. I'm not finding it immediately. Oh, here we go. Right. So here's the kind of symbol for Caduceus. It's not. That isn't actually the most simple form. Yeah. Okay. All right. So if you go and look at coinage, maybe we can see it here. This is the basic symbol of Caduceus. It's a rod with a circle and this little bit up the top here. You can go and find many examples like that on, mostly pre-Christian coinage. Here's another example if I can get it up. Is it going to let me do that? No, it's not going to let me do that. I should try this. So when I break my computer again. Okay, so here you've got the wings and these kind of things going on, right? There are highly stylized versions of this, I think it's just like a circle and then the two tops of the snakes kind of. Okay. All right. So I'm going to show you this image in stupid res, because why not? We can do that, so let's do it. Right, so this is from the 19th of April 2022, so nearly 2 years ago now. And here it is, and we, like I say, we have this in stupid res. So this is our beautiful iron-rich crenellated microsphere here. Very, very nice. I don't know how big is that one. We've got a scale over here. This is 50 microns. Two of those is, what's that, like, it's 10 microns. 10, 15 microns across maybe? I don't know. It's not 20. It's at least 10 microns, okay? So that's our sphere. From its base here, we have a plume of material coming out that we identified before. This plume coming out, these would be mixed elements here. And so it kind of made its way down here. I think there's some, twistiness going on down here as it came here. Here is our Caduceus here with our vortex here. And it even has the hole. It even has a hole up the middle here, right? Just like a tornado. It's just hilarious. It's utterly hilarious. So I believe that the initial impact was here, the touchdown. There was a bit of splay from the two sides of the substructure. And then it came up here and you have the vortical column. And this is the Caduceus head. These are the two snakes. And this would be the bit that held the ball in place. Or rather, it's just going around it, as it were. And these probably, I didn't analyze this one, but looking at the colors, the black here will be carbon. We know this is oxide of zinc and copper, and therefore this would be somewhere in between. So I would imagine this is a blend of things like silicon and oxygen, and I imagine these crusty big bits that's on top and this crusty big bit that's over here, this would likely be calcium, as was observed in the other ball lightning breakup on the same sample. Okay, so I will share this image for your viewing pleasure in the blog, but yes, I think it's becoming extremely clear how these things form, how they break up, and the fact that they have a lot of matter that gets caught inside, almost certainly in a coherent state, therefore you can have more matter occupying the same space-time. And then when the pressure is released, the magnetohydrodynamic pressure, but specifically the phase singularity of the fractal toroidal moment, it has to release the matter that can't be maintained in phase and in a bosonic state so that it can occupy the same space-time. Okay, so it just spews out and it goes off like a rocket, yeah? Okay? So seeing this, for me, was really rather spectacular. I think this, for me, is one of the most special images that I've been able to capture in this whole journey. And thank you very much to Henk Jurien for providing the sample to me of the Vega Valley from which this came. And thank you to all of the people that supported the scanning electron microscopy. Particularly want to give a shout out to Charles, he knows who he is, who actually helped fund the analysis of this at the time. So there it is. We have a very, very beautiful indication of the tail, which we were talking about last week, but in ridiculous resolution here and ridiculous clarity. This is what it is in my mind. You know, I'm very, very conservative, but it's getting to the point where this is absurd levels of proof. I mean, literally absurd levels of proof. Okay, now, what we have been showing is that these things can interact with the hardest substances known to man instantaneously and fluidize them. And then once they finish with them, take them their fill, they'll spit them right back out, or they'll shift them round to the side and they'll freeze out again. It is absolutely incredible what these little beasties can get up to. Okay, so what we also found with the VCS5 RT is this. That what can go in there, and we saw this in the original ultrasound experiment that I did in 2017, or that I videoed of Suhas Ralkar. When you get one of these toroidal moment structures, they can pull in smaller versions of themselves and they become part of the overall structure. Okay? Now, if you can imagine that this has a weak point here, this is the Sothic triangle bit coming in here, and all of the material is coming in here, and they are self-similar structures coming in, that when they spit themselves out, they are also self-similar structures. So it is not surprising that you would have smaller balls coming out of the material, of the structure. If this was in fact the main structure, it might have spat out smaller little balls that were in there. Plus you also have the balls within the substructures that made this the core of the overall toroidal moment. Okay, so I believe that we in time will find better versions of this where, yes, we saw calcium rings in here and so forth, and in the center there was iron structure here, iron structure here, iron structure here, and also interestingly, in the center distance between the outside and the inside of this outside crust, there are little balls. There's a ball here, there's a ball here, there's a ball here, there's a ball here. Maybe there's a ball here, I don't know. But I'm getting a sense that these outside crusts could also be made of something similar. Okay? The next point we shared in Ode flux capacitor. And again, it's eating the material here, the copper oxide. It's consuming it. And it's forcing the toroidal moment structure, which is resolved quite nicely because the copper likes to spin round these things, as we proved in another set of images from Binzhen Huang's DHX2 device. They suck a slug into the bottom and they wrap this material around themselves, but it actually ultimately becomes part of it and transmuted as well. And I'll talk about that more in the future. But it cut this channel in here until it crashed itself in. In this case, this is a dead one. The subtores have come out, and those subtores were likely the cause of the phase singularity that was keeping all of this matter in bosonic state. And as the pressure was released, the matter was reborn into this literal tornado-like structure. that came out and it laid itself down on this other one that is over here. Now, what I shared yesterday, or rather this morning, just 12 hours ago, just over 12 hours ago, was an analysis I did of the VCS5RT reactor core. Totally different type of reactor. This represented 4 of the tubes that were presented in the paper in Nature Scientific Reports. And here also you have one of these phosphorus containing tores completely broken up, and you have the vortical deposit coming down here, and this would have been the bum where it was feeding, and these turned out to be slugs of copper that had been almost certainly pulled in here. Now you can imagine, as this was crashing into the surface, if these things were spinning around on the bottom side of this, if they were spinning around, then you can imagine that they would bash into the material. Potentially that could be the way that some of the damage is occurring in these systems. My one regret with this is I was running out of time. I was going to be flying later that morning, and I got a sense that the tungsten filament was about to die because it was doing some weird stuff. You can see it on the video that I shared this morning. And I thought, basically, I have to be quick. And since I had found this, and I also found a similar structure that had phosphorus in it, it was done. For me, it's done. Certainly, both of these 2 reactors from Binzhen Huang are helping to completely rewrite 100 years of misunderstanding about what cavitation is, in my view. Cavitation is much more interesting than just a single-sided collapse of a bubble or spherical collapse of a bubble. It would appear that inside those spherical structures there is substructures which may well be in this superfluid medium, which doesn't normally interact with material, but in my view manipulates the way electrons can behave. And so in my view, this is an equivalent structure broken up, and my one regret is that with the lack of time I didn't see if this sphere was an iron-rich crenellated sphere. It would have been beautiful to show that, but I will get some more time in due course with this sample and we'll see what we can see. If we can find this one again, I'll see if that is actually an iron-rich crenellated sphere. Now, the next one I want to show you, we did a big video on, so I'll just show you this, and I'll show you the little video of the sacred geometry structure coming down. Now, when I'm showing this, I'm actually imagining you have your apple structure. So if we're representing the torus here, okay, and let's imagine the apple is around that. The actual tornado is reaching down and it's touching down onto the ground. So like the structure's coming in like this, and then what happens is as it's coming in like this, it kind of gets pulled back on itself, and the tornado reaches down and touches to the ground. So it's not pointing out that way. It's not the tornado is above and it's just directly reaching down. It's kind of reaching down at an angle like that. Okay, if you can imagine. So the tornado is going in this. The fractal toroidal structure is going in this direction, but the tornadic beam is bending down like the finger of God that it is, and interacting with the material. In this case, we know it is steel and steel oxides of that it is, and any material that has been synthesized or deposited as a result of the internal combustion process. And I talked about it touching down here, and I said that these areas in the bottom right here were due to the cutting force or the fluidization of the disruption beam interacting with the surface. I said it crashed here, slightly lopsided in its impact, leaving this circular at the mean square radius. It came along here, it had a few standing points here where the tornadic vortex interacted for a period of time, and then it got locked in this position as it crashed downside and left this half apple impact here. And when it crashed in this point and it crashed in this point, you had one set of substructures coming out here and another one coming out here with our iron-rich crenellated sphere. It then, probably because of this, and because of the loss of some internal structure as it was all self-organizing, it deflected over here and it started interacting with this surface. Now, I believe that in the next 20 to 30 minutes, I will prove that the channels that you see here are in fact the result of the tornado that comes out of the fractal toroidal geometry, out of the apple part of this structure. And I hope that it will be fairly conclusive. Okay, so yeah, it's a real honor to be able to share this with you. It's been a long time coming, and you know, you have these things in your head, but you know, this set of data from these selection of experiments is ridiculous, absurd levels of proof, in my view. This is extraordinary proof. Extraordinary proof. Okay? Anyway, I shan't label it. We're going to have a look at what real tornadoes do. Okay? So give me a second. This, my friends, is the mark of a natural tornado. And you can see it really extremely damaged this hay barn, spreading the hay all the way up here. And you can imagine the hay bales running along the ground here and just disintegrating. These buildings here are basically completely vanquished, totally vanquished, right? This building here is completely vanquished. However, there is two buildings here that look like they're not in bad condition. And that was right in the center of the channel. Where have we seen that before? Have we seen that in these points here and here and here? There's this stand in the center of the channel, which is not so damaged. The next thing that you will notice is that there is a hard line here. It's got waves, but it's the hardest line there is. Over here, you've got the loop, de-loop, 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 de-loop. And when I see this, what does this remind me of? What does it remind you of? I would suggest that it reminds you, or it certainly reminds me, of some of the interaction, or rather the appearance of coherent matter traveling waves in flight. So, with any luck, I'll be able to show you what I'm talking about. Hopefully it won't die because I'm loading PowerPoint. It's very expensive in terms of resources. Let's see if it's going to do it. Okay. I am talking about... play. Okay. I'm talking about these little puppies. And you can imagine, possibly, that this is a loop, de-loop, 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 de-loop. And this is a loop, de-loop, 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 de-loop. But it's like two structure, and one moves a little bit more than the other. Yeah? This one's, you know, the same all the way. So could that explain what is going on here? This is the coherent matter wave beam by Slobodan Stankovic. Charge separation of HHO gas going through extreme hydrodynamic shear through a carbon crucible, producing this almost non-diverging vortical beam. And that inspired the classified plasmatron work to be put out there by Anatoly Klimov, who is sadly not very well at the moment. And you can see the spiral beam coming in and hitting here, and it splits into two spiral beams going off in two directions. Where have we seen that before? Spiral beam here, okay? And here's a whole bunch of these things. So I think probably these kind of loop-de-loop-de-loop things might be something like explained by what we are seeing with the natural tornado. Of course, the natural tornado is restricted to a flat surface, whereas this tornado is freely moving in air. And could that explain these kind of M&M tracks that we see here? It's a very nice spiraling tracks here where they're not constrained. Again, M&M track here, but it's slightly changing its periodicity, although it might be its relative position to the camera that's causing that. Okay, very large moment here. So you can imagine that the distance between the loops being the M here and the M here, and the M here is far bigger, it would appear, than these M's. Okay, these M's are quite tight. So it could be that the forward motion compared to the toroidal rotation angular velocity allow for the observed periodicity in these structures. Okay, so I'm going to kill PowerPoint now because that's going to be a big resource hog here. Whilst we're still in one piece, I will continue. So, this for me was a very, very informative image. Total destruction of these buildings, right the way flat out in Washington, near Washington. And this was presented in the Chicago Tribune. You can go and have a look at it here. There's actually an image of a whole bunch of new cars in a parking lot, and they're all piled up and spiked into, like there's a whole lot that have just been put into, like you've tried to shove a load of cars into a plug hole. That's what it looks like. So I encourage you to go and look at that, bit.ly/torn-ct. Okay, so you've got a hard line on this side, and you've got this wavy line on this side. The next image I want you to look at here is this. This is tornado damage photos, 13 days of devastation in the Atlantic. And here you can see that the grass has been stripped on one side of this line, and the top right here, and almost no effect at all on the left side. You've just got a few residual bits of debris, okay? And, you know, you have one poor mobile home here that is being completely destroyed. Poor people, really, honestly. And you have a couple here that have barely been touched. And this is a real signature of these type of effects. It's like all or nothing, okay? Now, I'll say at this point, someone had a quick, thank you very much, David Studwell, that's very kind of you, really. If you imagine you've got a tornado and it's going over the ground and it's picked up stuff, right? When the tornado weakens, the stuff doesn't continue going out the top, it just falls back down, doesn't it? Right? Why wouldn't anyone expect the same thing to happen with these microball lightning? Thank you, Bo Sinclair. That's very, very kind of you. But it's even more than that, because you end up with a shield, this iron-rich crenellated sphere, into which you have dumped fantastic amounts of material in a bosonic state. So not only does it want to fall back out through the way in which it came, it's a fantastic pressure. It's a fantastic pressure. And so out of your lead sphere, which is only going to be like a micron or two thick, so it's really quite a soft metal, okay? But this fluidized atomic carbon spews out, right? And that's the way it goes in is the way it comes out, right? In, out. That is how I'm saying this occurs. And it's kind of like a tornado. A tornado would suck it up, and then when it fails, it would just drop back down again. Except in this case, you have pressure. You have intense pressure going on. Right. Now, what I'm going to show you next is incredible analysis of the 2021 tornado that occurred here in South Moravia, where I'm living, down on the border between the Czech Republic and Slovakia and Austria. It's an incredible study. I will post the links. There's so much we can learn about what is physically observable from this. Thank you very much, Craig. Really, that is really appreciated. Thank you. Thank you, guys. Okay, so this is a stunning study, and did it hit a trailer park? No, it actually hit brick buildings, lots of them, and you're going to see that. But what I have to show you in this, and then when we wrap up at the end, it really gives you food for thought. But I believe already we've conclusively showed the structure of these things. We have conclusively showed that there is no material, and even with the diamonds in the Neil Creighton Gold's Lion reactor, literally these ball lightning were able to consume diamond. So there's nothing that's harder than these things. These things can damage literally anything. They can eat through anything. Okay. All right. So let me get up this PDF for you. And think about what you're seeing. I'm going to show this once more. And I want you to think about what this implies. What this implies. Yes, we've got this hard line here. We've got this hard line here. But the tornado is traveling in this direction. Okay? Traveling in this direction. Left corkscrew. Okay? What? And we can see the material's pushed that way. So it's definitely traveling in this direction. What does this side differ from this side? What does this side differ from this side? And how would that manifest itself if there was a lot of captured material? I want you to think about that when I get up this PDF. Now, this is a huge resource hog, so let's hope this doesn't kill me as well. The damage survey of the violent tornado in southeast Czechia on the 24th of June 2021. So thank you to Tomáš Pučik, David Riva, Miroslav Šinger, Miroslav Staněk, and Peter Gronemeyer. Okay, we don't need to read everything, but here's your first things. These are the classifications of the claimed wind speeds within certain types of tornado. And we are interested in IF2 through to IF5, and this particular tornado was in the range of IF2 up to IF4. And just for context, what is IF4? That is equivalent to 376 kilometers an hour. This is what Takaaki Matsumoto is referring to. Fluid dynamics does not explain the behaviors of a tornado. Okay, and this is the implied speed. Okay, and then that in miles per hour for those of you that use real units. It's 234 miles per hour plus or minus 17, right? So an IF4 can actually be 376 plus or minus 113 kilometers an hour, right? So this could be getting on for 500 kilometers an hour, Okay, think about what that means. If you were driving in a car and you were driving into a wall at 500 miles an hour, I'm not sure you would fare very well. But is that really what's going on? I don't know. Okay, here is the track. It landed down just east of Břeclav. Břeclav is a kind of border town between the Czech Republic and Austria. If you just go down here, you're in Austria. This is the Slovak border here, okay? And they say most of the damage here was the initial downdraft. So this area here is, or rather this area here, is largely equivalent, I would say, to the impact, I would say, of this point here, okay? This kind of area here. So this is the initial damage, but when the actual tornadic structure comes in and hits the material, you really start to get the tight focused beam. And you might say that it is also equivalent to the initial bit down the bottom right here of the impact of a ball lightning like structure in the thunderstorm generator of Malcolm Bendel. Okay, so back to our PDF here. Okay, so it's impacting there, and the red areas are IF3 and these purple areas are IF4. You're going to see most of the key features here. So this is a power pylon, and you can see it's literally coiled up. It's coiled it up. It hasn't just knocked it over, it's coiled it up. Okay? Of course, it's got the T-bar at the top, but it's just the way it's done. It's just spectacular. It's a 400 kilovolt power line. Now, this, to me, is one of the seminal images here. Right. For reference, I think it's important to, again, remind ourselves of this image when it does it. This side has the hard line. In the center of the thing, the buildings weren't flattened completely. Outside of the center, they were utterly, completely destroyed flat. This side is a little bit less of an interaction. Right, let's go back to the PDF here. This is the tornado motion. This is the tornado motion. And on this side, the pylon is broken down this way. Right? Just like a wheat sheaf in a crop circle. Okay? You can see that the stands of the trees here are smashed over this way. Now, here, the stands are not smashed either ways, right? They're just standing upright. They've been stripped of many of their branches and they've been stripped of their leaves, but they're just standing upright. Here, down here, it's pushing back this way. It's pushing back this way, counter to the direction. And here we have another one of the pylons from the power line snapped off at its base, literally broken at ground level and snapped off. Okay? Two striking things. This area is relatively clean. Even when you've got the trees knocked down here, they're relatively clean here. It's so powerful on this side, which is the additive direction. So you've got the tornado motion, plus you've got the vortex, and they are adding together, right? In the additive direction, it's literally stripped the crop down to the ground, right? Yeah, so RJ is saying pushing down on the right, pulling up on the left, and twisting the living daylights out of the middle. Yes, right. Okay, stripped to the ground. Down here, what do you see? You see deposited leaves, deposited branches, and deposited trees. Okay? So, on the backside of the tornado, you actually get things left behind. On the front side, it just continues to strip. Okay? So that is something around here. This is absolutely fascinating. Terrible tragedy for the people. A good number of people died. This is in Hrishki. And you can see many of the buildings, and these are not wood buildings. They don't build, well, they do build shanties. They build these garden houses in the Czech Republic out of wood, but predominantly it's brick. Okay, so ridiculous damage. Now, here's a couple of things. The trees have been literally stripped, completely stripped, okay, and laid down. Here you've got like twisted metal, unrecognizable thing. I don't even know what that is. Is it a tractor? I don't know. Lifted up stuff. But here is something that really should shock you. Because if anyone knows how strong a shipping container is, this tells you something that's going on here. Now, is it because of those up to 500 km/h winds? Or is it that the structural strength of the metal was changed to a degree because the electron's ability to act as electron was manipulated by this intense flux of this weakly interacting material? I don't know. But certainly we were able to take HHO and turn indium that normally melts at 156.6 degrees C. We were able to change it into like a jelly-like substance and capture that on video. And it was only after it glowed incandescent, like as bright as a tungsten filament light bulb, and we saw jets coming out which we identified under SEM as being literally like volcanoes, synthesizing all of the elements that we observe in these processes. This is using a Mars gas. Did it then melt thermally and then drip? The vortex that was going on, those vortices that were going on with this coherent matter, were manipulating the way the metal behaved. It turned into a rubber sheet. It didn't elongate, it just flapped around in the jet of the breeze of the HHO, or the Amasa gas in this case. So what really is going on here? Are we determining wind speed really from the damage it would take if we were to ordinarily damage something with wind speed? Or is what's going on here something a little bit more interesting? Don't know. So here we have the IF4, these really incredible strength winds. Okay? And what you start to see is these very, very clear stripping actions where you sometimes get areas which are completely unaffected. Total devastation. Here with this church ripped off the roof, but look, the roof is completely removed all the way down here and here, but this house looks like nothing's happened to it at all. It's like completely fine. No problem at all, right? Total stripping, right? Total stripping. This is in Moravia, Nova Ves. Okay. Here, I don't know if anyone knows what a kohlrabi is, but this particular area here, it stripped all of the leaves off the kohlrabi. Okay, does anyone know what a kohlrabi is? I'll bring up a picture for you, so it's not guesswork. It's a vegetable that we tend to eat a lot of in Central Europe. Here it grows very well. So this is what a kohlrabi should look like. If I can get it up, so to speak. Right, this is what a kohlrabi should look like in the ground, and that's what it happened there. So it stripped every single piece of green leaf off that kohlrabi. Yeah. Here is your IF4. This IF4 has completely destroyed this brick building. It's literally totally... This one has only got foundations. This one, I don't know what that is. Is that the foundations? I don't know. It's just totally gone. And here we have total removal of building. And here, this building looks fine. It's just totally fine. Okay? Here. This is a brick building. No more. Terrible, terrible. In this case, as I understand it, it crossed over the railway line here. And there are lots of vectors that they're drawing here of the various moments that were observed. Here you can see it came down here, it stripped these buildings or whatever it is, this material here, totally flattened. But these buildings relatively intact. I'm not even sure what that is. Is it a bus? I think it's a bus. Was a bus. You can imagine that was flying up in the air. Various pieces of metal, twisted, trees stripped. Again, here, completely stripped crops. A piece of metal like it's become a piece of fabric. Now, where have you seen that before? Where have you seen metal that looks like it's become fabric? Okay? Think about it. I mean, tornadoes can do really weird things, like take a matchstick and put it sideways into a tree. There's these classic photos of an actual compact disc actually embedded into a tree. And of course, you know, why didn't it shatter or whatever? Well, you can certainly imagine a compact disc building a lot of charge. Okay, so there's a couple of shots coming up now which tell, for me, like, the most important single shot is of a solar panel array. I mean, look at this. I mean, these houses are utterly gone, totally gone. No problem at all over here. And they're probably having a garden party over here. Oh dear. This for me is a big story. Now, like, if you have solar panels in Texas and where you get big hailstorms, you know, that's not a good idea. But here you can see the bulk of these solar panels over here are completely untouched. Very brittle things, completely untouched. Okay? Over here, essentially completely untouched. You can imagine a few pieces of detritus falling down out of the sky and damaging the odd panel. But where the actual tornado came through, it's literally stripped the panels. They've been removed, and there's a hard cut-off line, you know, between panel that's gone and whole panel that still lives. Yeah? You can see it came over these buildings here and stripped this building clean. This, for me, is extremely important. Okay. Probably that's all I want to show. Oh, no, here's another example. Look, similar to what you saw outside Washington, you have crop stripped from the ground, cropped less stripped from the ground, and there is a green line running through the middle where there's less damage. When I see this green line, I think of that hole in the tornado at the bottom in the Henkure and Vega Valley sample that I led with today. Okay? Very hard line. Softer line on this side. On this side, you can see material has been pushed back So you basically know that the tornado is traveling in this direction, and the core of the tornado is there where it's green. Okay, terrible, terrible devastation. Just, I mean, it was my guy that rents the office with me, Emmanuel, he went down there and took a lot of film and stuff. I think he took a drone down there before they banned it. Terrible. Yeah. Okay. So it's the extreme nature of these things. So I want to thank again the authors of this report. Please do have a look at it. Here's our authors: damage survey of the violent tornado in southeast Czechia. And for me, the real money shots is this one, which shows the deposit, the no deposit, the extreme stripping, the pylon pushed down one way and the pylon pushed down the other way here, showing a very different kind of behavior. And then these chopped off, absolutely cleaned to the ground, absolutely cleaned, right? Cleaned. Think about that. And then down, where is it? Here. So certainly the fluidizing or the rubberizing of metals, which is suggested by this and the shipping container, in my view, having seen what I've seen these things do in the lab, particularly with the Mars gas. Okay, and have shared on video. This extreme cut-off line in very brittle material. And lastly, this extreme here with the green channel through the middle. The green channel through the middle. Okay. You might be wondering why I'm showing you all this. Well, I have a point. You know I have a point. I always have a point. Right. I'm going to go into 3D now. And this is one of the 3D object sets that I believe I've shared. I think I've shared them. I should have shared them. Let me see. And this is true of all of these, and I will do a little video or image of these and put them in the blog to illustrate my point. Where is that? Where's it gone? I don't know. I've lost Lightwave. Where's it gone? Okay. No, I don't know where it is. It's hiding. Oh, there it is. No, it's not. Excuse me whilst I talk to myself. I'm going to put the whole music on. I'm sure you're all happy about that. Come on. Why would that disappear? I should install the macOS version. Probably work better. Right, there we go. I've got it for you. Right, what I have here is the relief map. Okay? And this is the initial touchdown area. So where am I referring to here? Let me just get it up. I am referring to this area down in the bottom right. So we're going to be looking at this area here and these areas here. So firstly, the bit down here with the wave pattern on here and these circular sections cut out here periodically. This here is, in my view, exactly equivalent to the tornadic path that we showed outside Washington, and also to the marks observed in the quartz of the Lion reactor, in the Dr. Alexander Parkhomov boron nitride, and in the Dr. Takaaki Matsumoto copper. So it's these curved sections with the individual sections cut out in between. That is what I am saying is going on when it's interacting here as the initial touchdown of the tornado. It kind of sucks itself in. It sucks itself in a similar way to the Binger and Huang one here did. It initially interacted and then it pulled itself into the ground and it caused itself to crash into the ground and leave this initial impact mark here, which we can see when I play this, crashes in there. Okay, the Tornadic column is correct width. It's the correct width here. It's the correct width here. And some people said, oh, this is just a scratch. It's just a scratch, right? Well, I'm going to show you it's not a scratch. And I could have chosen this section, which I imaged. I've already shown you an image of this, and you can see the same effect there. And it's very clear up here. Okay, what am I talking about? I'm talking about that in 3D here. So this is the area where it crashed in. You can see that on this side, which is the side which we had the hard line in the Washington photo, we had the hard line in the Moravian, Czech Republic tornado, you have it cut out deeper. I can show you that. It is definitely cut out deeper. And probably I'm going to rotate the object here. You can see here it is definitely cut out deeper on that side. Okay. Here on the side where you don't have the combined movement this way and you have the backwards opposite to the movement of the tornado, you have material deposited. Okay, so it is still cut down, it's still damaged, but it's flowing back on itself in this direction. And you can literally see that the wave has come up to a peak, the wave has come up to a peak, the wave has come up to a peak, the wave has come up to a peak. It's like the wind was blowing in this direction, right? This is cut down, it's really cut down, but the waves are coming in this direction. This and the other data that I have shared from this impact site in Malcolm Bendel's 8-year-old experiment that were ran in Melbourne, in my view, adds to the ridiculous amount of absurd levels of proof that we have shared in the process of O-Day. Okay? So you can explore this yourself, but in my mind, it is done. This is what causes strange radiation. This is coherent matter waves manifest. This is total interaction. This is the irresistible force that nature gives us. It is the gods with a little G toolbox. And for me, I could have chosen either of these three sections to do it with, but you know, I just did this one first. And there we go. Right? So for me, what you are seeing here is exactly and precisely equivalent to things that natural tornadoes do, and in particular, not that, here, this thing here. Okay, material is stripped out as was shown in this. Is it going to show me? Where are you? Where are you? As we see here, hard line, center boundary, material deposited back. And where is it? Yeah, all the way up here. Yes. Not so much damage in the middle, material put that way, deposited material put back. Okay, that is what we are seeing here, my friends. And before I do my little bit of crazy, because we haven't had enough crazy recently, so I've got a little bit of crazy to add on to the end here, I will take your questions. Okay, so do you have any questions? Why do we not see a line of less affected material instead of periodical spots? I think there is effectively a line in the middle here. I think it's clearer actually if I go. Where is it? And like I say, it's a design plan. When you are doing tornado work, not every tornado leaves the perfect mark. You've got to look at the signature and work out the dynamics in bulk. Like it's not going to give you the perfect answer, is it? But tornadoes in themselves do get stuck from time to time, and they leave patterns. And you're going to find the same thing. It's the same force. In my view, it's just a scale invariant force. So, what I was going to show you here, there's a harder line up here. Probably it was, sorry, up here on this part of it. Probably it would have been better to do the example here, and maybe I will, right? But there is a hard central line here on this. Maybe I will load that one in. Maybe, I don't know. I need to set up the object. I'll do a separate video on that, but anyway. It's cleaned off more on this side, and more material is deposited back on itself here. Okay. Oh, thank you, Vanilla Isis. Very kind of. That's a great. Cheers. Yeah, I've not done the little bit of crazy yet, but it's coming. It's coming. So, what N is the tornado? We can. I'm not sure what you mean there. What N is the tornado? What? Oh, what N level? The tornado is always. Sorry, the sub-tornadoes, they are the Sothic beams that come out, or the disruption beam that comes out through the center of the Sothic triangle, or on the boundary of the Sothic triangle that's got some dimension. So as long as you have 2 or 3, possibly 4, but certainly with 2 and 3 substructures, you will get beams that come out of the overall apple and even out of the non-radiating boundary. Okay? So in that part, that's why you see some of the structures in the Binge Hang, they kind of crash onto their side. They're crashing onto the side, I believe, because the substructure disruption beam is coming out, and it's kind of interacting with the surface, either positively or negatively, in one way or the other. But mostly, it's the main disruption beam and Sothic triangle kind of torsion field that's effectively coming out. Rippy for Freedom, did you speak with Dan Winter about implosion and negentropy in the donuts? Yes, I have. I have also explicitly told him you cannot have negentropy without having entropy, because the yang does the entropy. It breaks things up. And the yin does the negentropy. But collectively, they do negentropy. Or collectively, they do entropy. So you can't have a universe where everything is negentropy. You need some give and take. You need some balance. You need some yin and yang. And it's just what it is. Like, you can really want everything to be negentropy. That is life, in my view. And these structures, these, whatever you call them, plasmoids or microball lightning or whatever, these cavitation structures, they are acting like living things. They live, they grow, they subdivide, they die. They eat, they poop. They leave something behind themselves, right? In a way, they organize the environment by disorganizing it. They are a force of nature and I would argue they underpin, you know, all intention. Lithnic, we talked about doing a live stream at the Cosmic Summit, not the Cosmic Summit, the Galactic Summit. I don't know, the one I went to in France. It will happen. So many tornadoes have multiple tornadic substructures around the main core. Some are single. Okay, yeah, wouldn't be surprised. So Bob, can the torsion fields be open or closed loops? Well, within the tor itself, it's going to have, you know, some of this going on, but it's confined within it. It's when they bleed out from the n level, but the n-1, if there's on the n-1, or in fact on, essentially it's on the n-1. If the n-1 has less than 4, this is why I think the swastika and the salvestica are so important, because they, as we've shown through experimentation, they are the ones that start to become a stable structure that doesn't have this this structure, the structure that I showed you earlier. Where is it? This structure. And we've seen it on Hutchison samples, but we nailed that part of the process when looking at the 15mm ball lightning cut. So you don't get this kind of thing, the overall 9 shape, the shape that I went for here on the cover image. You don't get that if you have 4, a swastika in the n-1, in my view. Definitely not at 5, and certainly not at 6. 6, the flower of life structure is really the one that, you know, it's the flower of life. It does those things, but you can definitely get things going in a much more focused way when you have 4 or more substructures. Okay. Marble says, do all this boil down to getting much more energy from the same amount of fuel compared to traditional engines? I mean that, and I've got something covering it up, that is the elephant in the room right here. Benjamin Huang told me he's got a stable heat generation system that produces, I think, 30% more thermal heat than electrical energy goes in. That is a very, very clear signal. A stable reactor is fantastic. And we have seen that 100% certainly, in my view, it is doing everything that's necessary. And it's doing some nuclear reactions. Now, some of the nuclear reactions are, it might be a least action process. Like some of the reactions are actually using energy, and some of the reactions are creating energy, or rather releasing energy hidden within matter, whether that's through release of binding energy or actually decay of baryons, you know, various different things, fusion, fission, whatever is going to give you energy. The net balance is positive, is what I'm saying. But there's many ways to improve this, and I'm going to be working with him and other people developing aspects of the technology to understand how they can make safe devices that produce more, whatever the positive benefit you want, whether you want more cooling, or you want more heating, or you want more glowing, or you want, you know, all the different ways this can manifest, which is all of the most interesting things you'd want to do. So in the case of the thunderstorm generator, you know, sometimes it would appear, according to data, you know, there's 12, 13, 14% oxygen coming out, and the balance predominantly is CO2. Of the detected gases, obviously a good proportion of it is nitrogen and so forth. But sometimes the CO2, rather than being that balance, it can get down to like 1%. This is what is claimed. You know, these things will come out in the wash, and it could be to do with the vibrational state, it could be to do with the shape, It could be to do with the treatment of the metal and stuff. So these things will resolve themselves, but we're waiting on more data from isotopic analysis to confirm whether it's a stepwise transmutation, which I suspect it is. Certainly the cavitation work of Max Formachev-Zamolov would imply that it was, and so forth, and also the work of many other authors, including ourselves, and people working with the project, and Binzhen Huang. So like a lot of these are showing stepwise transmutation, which makes sense. So we're going to find that out in the coming weeks, and you know, my luck's got to run out at some point, but I'm feeling quite lucky so far. Right, Penguin. Well, yes, we've got a crazy bit coming up. A little bit crazy. Yeah, you can load these into whatever 3D application you like and verify what I'm saying. You know, you can see in the live video that I did with Phil Dubois, who's now in America and carried a selection of latest thunderstorm generators and older thunderstorm generators to be tested by third parties. So that's really very cool. So we shall see what comes out of that. But this is as it is. This is showing the behavior of a tornado. The same thing that a tornado does at scale on Earth. And I have no reason to think that these structures could not be built at any scale and wouldn't do the same thing and interact with matter in the large, broad sense. I mean, when you're coming through a piece of material like this, there's going to be crystals that are bound together stronger than others. There's going to be slightly different deposits of previous material on the surface, and the actual structure is going to be excited to varying degrees as it travels along. It might be traveling between excitement nodes or energy fields or vibrations and stuff. So, you know, you kind of have to see this in a kind of, it's a manifestation of the answer to all of the parameters that are feeding into the structure as it's doing its work, in the same way that it is in a normal tornadic interaction with land. Okay. Have you heard about the vases, and do you think there is a connection with these processes being able to deal with and heat pressure plus? If you're talking about the pre-dynastic vases, yes, I have. I've spoken to the person. I would imagine that these kind of processes could be used to manipulate stone. I've discussed that in the past. I think at some point we'll get onto some of the specifics and compare that to various things that have been said in the past. But, you know, I like this level of ridiculous levels of certain data, which you can share at ridiculous resolutions. That image here, for me, if I go here and I'll just minimize this a bit. This image here, showing the ball lightning breakup with the head here being the same, like the shepherd's crook or the, you know, the staff, the wizard's staff here, having the same essential radius as the main core of the ball lightning, and the Caduceus vortex coming down with the hole in the center. For me, it is just what it is. I mean, it's like, it's getting to the point of being totally absurd, like totally absurd levels of proof. It's like, I sent to my wife earlier today, Kim, thank you very much, Kim, for supporting me. I was saying to her, I said, I have never seen anything that I've been asked to believe in science in my life that has had this level of proof. I've just never seen it. It's like every single system that produces excess heat that involves these kind of features and these kind of processes, when you get down to it, there's an iron-rich crenellated microsphere. There's nuclear synthesis, very similar to stellar synthesis, and there are these toroidal beam interactions. It's just what it is. And it's like, as I said to you before, like the kind of mental gymnastics you have to go through to believe that this isn't how it is. I mean, it's it's like, oh dear, honestly, totally ridiculous levels of proof. So Hermes, yes, as above, so below. Yes, yes, I think you might see a bit of that in my little bit crazy. Hi, Phil. Back in the home of your heart, yes. I don't know if you caught most of this stream, but essentially I was showing very, very clearly that the tornado structure that comes out of this thing is exactly represented in the data I captured with you of the deep impact structures. And, you know, for me, it's done, you know, with all of the data that we've gathered and Matsumoto gathered and so forth, it's done in terms of, you know, understanding this kind of damage pattern. Oh, great. Okay. So good to have you here. Great. So Adam, who sourced the vase for Ben. Yeah, I think I've spoken to Adam as well. So he was on the tour with you. Great. Excellent. Great. So I'm really looking forward to meeting people that are able to come to the Cosmic Summit. I think George Howard is doing a fantastic job at doing promotion and building out the website. So thank you to George Howard there. And I just think it's really funny that, you know, what the whole one side of the Cosmic Summit is showing is that the end of the last era of understanding was probably stimulated by these things coming in en masse from the cosmos, and that our way back to the new golden age is actually to employ these things and understand them. Yeah, that's my view, and I'm going to stick to it. Right. So, are you ready for a little bit of crazy? Are you ready? Okay, here we go. So, in ultra analysis of the powder sample, the accretion sample from the VCS5 RT that we looked at and shared some more data from in the first part of the day, on the actual surface of the core part of the reactor with this Narugo image here, or actually this is a macro photography. I will do Narugo images on this sample and we might be able to get some even closer look at this. These are our iron-rich crenellated spheres. Some of these have got chromium in them. That's probably why they're extra shiny. And we talked about this, and I talked about in this presentation and have done and shown in others, and I talked about Suhas Raukas, where the toroid that is outside of this, creating this magnetic core, forces other material into the magnetic core, into the phase singularity at the center. And in the process of doing that, actually other smaller structures, magnetic charges, are aggregated in there that might be self-similar to the overall one that produced this. And I argue that these spots in the center of these calcium structures, here, 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 I believe are self-similar, but on a smaller scale to that. So, if we can imagine, little bit of crazy, if we can imagine that this was the bounds of a universe, okay? And I discussed before that, you know, one of these overall structures acts and behaves like a galaxy. So if this very large super galaxy is pulling in material into what effectively is a black hole, that inside this black hole, you have a totally different frequency and time domain, and these substructures that have been pulled in here and are swimming around inside this thing around the phase singularity at the center are effectively got their own phase singularities, okay? They are acting a bit like a universe, okay? Where what you are seeing here is the galaxies, right? And they're in their own little bubbles. They interact with each other. And you have this would be the tornado that comes out that feeds from the super galaxy here, okay, which would be feeding in here, feeding energy in, feeding these galaxies in this universe, okay? And if we looked around, you know, we'd only see out so far, and this would be the boundary of our universe. But as above, so below. As above, so below. Why then could we not substitute our galaxies in this structure, in this universe, for universes? Therefore, we have universes which cannot see the other universe, right? They have a dead space like this, okay? And these are universes in a bigger universe, and ad infinitum, and the multiverse, okay? But then, what we have found in these systems is that there's one side which takes apart matter, and there's another part that builds matter. One is a yang, and the other one is a yin. And the yin in our universe is left-handed rotation. And there's a debate, why is there so little antimatter in our universe? Well, maybe our universe is itself a massive topological monopole. And in fact, what you do is you don't only have a multiverse, you have what I'm calling a mirrorverse, where this has anti-galaxies, and it's all made of antimatter. And this entire mirrorverse is running on antimatter, and everything in here is built out of right rotation matter, okay? And the antimatter for the mirrorverse is actually matter from our universe. And in the mirrorverse, when they want to destroy antimatter, they do left rotation. Okay? Now, I'll leave you to ponder that as I just put one extra slide in that I need to illustrate something from peer-reviewed paper, which I believe was utterly and conclusively proven by one of the images that I shared from Binjuan Huang. So give me a second, I'll put you on the hold slide. Just to clarify the point there, like, this is just a yin-yang, and the yin-yang can be a yin-yang that's driving one little Evo in another universe, which is running on a different time and is running on a different spatial dimensions and frequency scales. I mean, it's just literally endless. And you wouldn't be able to see beyond this boundary. And this boundary is in these little boundaries, in these little boundaries, in these little boundaries. So just give me a sec. I need to find one image and throw in a slide here. Honestly, I wanted to have this done, but you know, you've got to do what you do when you can do it. And I'm doing it right now, on your time. Which one? Oh dear. Oh, I can take it from there, can't I? Okay. Nearly there. Honest. Okay. If you're still having trouble believing that this is the way it is, maybe this will help you. This is the vortex and anti-vortex pair, a selection that I took in Prague on the 28th of March 2024. We have the vortex and the anti-vortex here in this pair, which are a pair. And how is this related to mainstream understanding of the toroidal moment? Well, I will refer you back to a paper that I shared in, I think it was Ultra, an easy and quick way to Lena or whatever it was that I shared in a CC a few years back. And it's this. The hypertoroidal moment, as it's called in this paper in the American Physical Society from 2014. Okay? Of course, I'm sure refer to this as the fractal toroidal moment, of course. And depending on your aspect, you end up with a tor or you end up with an apple. But it's this diagram I want to show you over here on the right. There are two stable states. Okay? There is one where the magnetic vortex overall moments resolve going one way round, and there is another one where it goes the other way round. Okay? And what we are looking at here is an electric field of megavolts per millimeter, so up to 0.8 megavolts this way and minus 0.8 this way. And I think if you resolve that for these structures, I can't remember offhand, I did do the calculation somewhere, but I think it's about 7 volts between these two. And of course, you only need less than 1.5 volts to split water. I think it is that right? And you don't need much more than that to split hydrogen, do you? So these things themselves, potentially, I'm just throwing it out there, it's not quite a little bit of crazy, but it's getting close to being a little bit of crazy. There could be a potential difference between these that is able to break water. Yeah, well, I think it's 1.36 RJ for water. Okay. But yeah, 1.4 definitely, I'd say. So, given the fact that I think you can do the maths, when you can see that these structures are 20 microns across, okay, and so on. I think it will work out, and essentially that they need to be of a certain size before they can start feeding themselves. And maybe that's why you need to have these quantizations. Okay? Maybe it's why you need to have like a micron to start with, and then say 5 micron, and then 20 micron, and then, you know, so on. I think there's something to that. But what you cannot doubt in any shape or form, that this mainstream paper in the American Physical Society's journal, this peer-reviewed journal in 2014, specifically talking about the fractal toroidal moment that they call hypertoroidal, okay, leads to magnetic structures that are apples either with a right rotation vortex or a left rotation vortex. And we have conclusively proven that they can be produced on the absolutely stark raving looning bonkers macro scale. Not nanostructures, but stark raving looning bonkers macro scale. And I don't think it would stop there. So I just wanted to put that in there. I think there could be something to things being a certain scale that allows them to produce the voltage differential somehow, some which way, between them, that allows for the consuming of hydrogen and oxygen from water. Okay? We know already that they seem to interact with matter and weaken or change the way an electron bond occurs. Okay? Is it something to do with a field differential between these two that allows that to be very active process when working in water? Okay. All right, so like anyone in the mainstream that doesn't think these are based on fractal toroidal geometries, they have to go and explain why they're saying that these structures are based on these ferroelectric nanotorus here are based on hypertoroidal moments. Yep, no, it's the same thing. Sorry, it's just what it is. Okay. All right, before I take your last questions, I will remind people if they would like to come and ask me some questions in person and see whatever I have to say at the Cosmic Summit. They can go to bit.ly Cosmic Summit, and with their Boom 50 and the Boom 25, they can get some discounts on several passes. And obviously the plasmoid pass will be, I believe, the most relevant for myself and Malcolm Bendel and Jordan. And I hope that Phil will be joining us there as well. So that would be great. And we can talk a little bit more crazy if you want. Or we can talk hard facts that are reflected in nature. That are reflected in, let's face it, nature. Nature, 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 nature. Nature can't lie. O is nature, in my view. What a freaking special time to be alive. Yeah, Phil. Trench of extreme facts. Dash. Deal with it. What an absolute honor. Absolute honor. Do you understand? When you get this, it's propulsion. Don't need anti-gravity, you need propulsion. That works everywhere. Propulsion works in space. Anti-gravity needs a gravitational body. Nope, propulsion. Go and look at Rodionov's dark matter strings. He talks about neutrino rockets. We have shown the physical on-video evidence that that is the thing that's going on. We have shown it. He talks about tornadoes and how they interact with matter. You've seen the evidence today. You've seen the physical evidence of what these things do. We've caught them on camera, on video, and we have, across many independent authors, including our own work, these things doing this kind of thing that a normal tornado does, but in manipulating matter at micro scales. Okay. This can bend time. It can allow for fast and light travel, in my view, propulsion, energy at any point in the universe, synthesis of matter, desynthesis of matter, transmutation of materials, teleportation. God, it's a little bit simple. Oh dear. All these things are going to be obvious one day. Just totally obvious. And it'd be like, why didn't we think of that before? Oh dear. We got some fun times ahead, guys. Fun times. So beautiful. Such a beautiful future ahead. Okay, yeah, communication over vast distances. Yeah, I mean, it's like, I've talked about it in the past, but yeah. We mustn't let them do the holding dominion things over us with all of the different ways that you can manipulate reality with this. I haven't worried about nukes for a long time. I'm not worried at all. And it's pointless, because if they really do manage to get away with deploying them, then it doesn't matter anyway. And by the way, the spirit's eternal. It literally doesn't matter on any level. It does not matter. It's just a means to extract money from you, in my view. Permanent bogeyman, permanent disease, permanent climate problem, permanent this. And if you haven't got enough problems, start inventing them. You've got a problem. You must have a problem. Everyone's got a problem. You're special. All you should be worried about is not worrying about anything, is to focus on what positive you can do in your life. Just forget about if you think someone's wronged you. Just let it go. Just everyone can do positive things. Everyone can move the human condition forward and the health of the planet forward. Everyone can do that. It's about intention and will. And they've got very, very good at subverting people's intention and subverting people's will into desiring negative things. Just don't let them affect you. Just don't let them affect you. Be strong, know who you are in your core self, and work positively. Yes, Lifnick, love is the answer. Love is the key. Love is the key. You've got to love everyone and everything. I don't mean carnally. I obviously don't mean carnally, right? You know that, right? You know I don't mean carnally, yeah? Yeah, WV for truth. This allows to heal as well. You can see that this is an awesome force. It is, in my view, the most potent thing that exists in this universe. There's nothing more. It is the program. It's the program, and it's how to. It's like, you know, when you get those decoders or whatever. I can't remember what it's called. I used to use them all the time. Decompilers, that's what I'm talking about. This allows you to decompile the fabric of the universe and to compile it again. And, you know, the implications of that are ridiculously phenomenal. And it's there. These little beasties, they can do it. And they manifest differently depending on what material is in their environment, right? But they're all based on the same program. That's for sure. They're all based on the same program. Oh, I didn't want to do that. There you go. What an honor. Thank you, Claire. That's very kind of you. Yeah. We are literally somewhere in a mirrorverse. In fact, we're in a multiverse of mirrorverses, which is anything can happen. Anything can happen. Just literally anything. As long as you obey the rules. There's a rule. There is a rule that the universe runs to. And it is the rule that is encoded in the sacred geometry. That's it. That's the one rule. That's it. That's it. It doesn't need anything else. Everything else is a complexity that is emergent from that rule. And if you're not working in that way, everything's going to be hard. Everything is going to be the hard way to do it, or not the best way to do it. Ken Shoulders, he had to have known. He said in 2010, and I did the transcript, you can go and see it on my Steemit. He says, if there's something you want to do, and you want to do it well, this would probably be the thing that would do it best. Something along those lines. I'm paraphrasing, but basically anything of any significance you would want to do well, this is the thing you'd want to do it with. And he says, these structures are ubiquitous, which is essentially the same as saying omnipotent and omnipresent and quintessent. It's the playbook. It's the playbook. The prima materia, yeah. It's the prima materia, but it's the way it works. It's accessing the prima materia. But what is the linear substructure at an angle near the impact point far left? Here, this, well, don't know. You're talking about this little linear structure here. Don't know. Don't know. You know, you do get detritus that follow this structure around. So it could have been something that it picked up at some other point. Don't know. You know, what happens is, over time, things that look like they're a mystery become not a mystery anymore. when more and more detail or more and more examples come out. So maybe one day we'll find that this particular rod is extremely important, and we see it in many examples. I have not seen it as anything particularly special yet, but you know, it may come to pass that it is in fact very special. Right, there's even a subtor structure down here. And I know these are going to be calcium oxide. It's a fragment of it, by the way. Yeah. Absolute brilliant work, Henkurian. Having the courage to, you know, have 750 volts hanging around your barn and being meters away from it, you know. Nature doesn't lie, and it does the same thing every time. It's doing the same thing here, and it's doing the same thing here. It's just the same thing. So Ignoramus says data will sway. You know, what will sway is actual practical embodiments. You know, they can denial they like something that's transmuting toxic elements into harmless elements or desirable elements. They can denial they like the heat generated in Binzhuan Huang's reactor device. You know, but there's things that this can do and assuredly will do, that they'll have to wake up. There will be many Kitty Hawk moments. There will be many of these things that they have convinced themselves are impossible, or they've convinced you, not necessarily you now, but you in a former self, are impossible. And they're not impossible. They're very, very possible. And, you know, people will see these things and they go, that's not possible, but I can see it, so... Penguin, I think I think we can get the cavitation systems in line with Kladoff's claims. I think by using the geometry and using the understanding of what needs to be the parameter space and the additives in there, he used aluminosilicate as a 5% additive to the water, and it put the maximum COP from about 6 plus to over 11 times. And when you're getting to 11 times COP, you're far exceeding a heat pump. And, you know, the great thing about that is that you can actually drive the cavitation device using a water wheel. So you could use water coming over a water wheel through a gearing system to drive the cavitation system, which is then heating the water to steam. And you're just using the water that's at the bottom of the water wheel. So without ever going near any electricity, you can create vast quantities of high levels of energy. The Windhex for me is a fantastic tool, and I would like to see it reach its potential for recycling a lot of household waste into rapid soil, if you know what I mean. So like vegetable and other bio waste, you throw it in, it desiccates it, but it makes it into very, very small particles. And you can add glass bottles and eggshells and stuff, and you could make, you know, a good growing medium. That's what I would like to see. Direct recycling, like they have, and I've discussed this before, in India, where you get your spices and you go down to the corner shop, and they'll grind it for you for your meal that day. Yeah, Craig, you know, understanding these things, he's suggesting using hydroelectric dams to produce additional power. Yeah, sure, there's going to be those kind of potentials. Can ball lightning eat gamma radiation? Creating awareness, it can eat the things that cause gamma radiation. But I do believe that if you had this coherent matter skin, if you were inside it, let's say, not necessarily you want to do that, but if you were, you wouldn't see gamma rays from the outside, or if there was gamma rays inside it, they wouldn't be able to come out. So, but really you want to deal with the material and get rid of those gamma rays, or the potential for them. So we can convert plastics to another material. Well, certainly once you've got unlimited energy and very high temperature water, there's all types of chemical and catalytic processes that you can use to recycle many things. CC says, what are the Russians up to? Well, they do what they do publicly, and then they do what they do not publicly. But they have asked me to speak, and I'll probably speak within the next month or two at the weekly conference. And of course, I will share what I share with them. A lot of it will be things that I've already shared with you, but I will kind of like hone it down, and hopefully I will have it translating for them, and then I will produce an AI translation for them. Okay, so I'm going to look through your comments. If you have any specific questions you really feel need answering, please put them on the blog at remoteview.icu. For this, I will put some of the materials that I've shared here and links to the material over the next couple of days on the blog. So in a quick review here, if my machine doesn't break in the intervening time. This was Ode Tornado, and we discussed this 9-like pattern that comes out of a 2-tor structure, whether that's a structure on the outside of a 50mm ball lightning burn, or disappearing material in a copper pipe in a Henk urine Vega experiment, or if it's on a 2007 aluminium block by one John Hutchison, or on a 1986 sample of steel by John Hutchison. It occurs in nature anyway. Okay? When you have this 2 structure. In the wind hex, we're trying to create a focus beam with a destruction point at this point and sub-tor destruction points. So when we've got our charge separation in here and our moisture, it really should start to hit the process quite nicely. And of course, we looked at the the propulsion system, but there is this device which was based loosely on the Searle device, and I think that Sergei's confusion with how a small device produced such large temperature differentials, showing one of the key principles of the effect, I think that's because that device probably was closer to the sacred geometry. And I think I would speculate that if we use that understanding, we would be able to create devices which have find it far, far easier to create this effect. Bear in mind, that in my view, this will be causing beams that will effectively disrupt time and the energy within your body. I don't know whether it will be positive or negative. It might be whether you're in a certain physical state. But it's as well to be aware that this might be the case. Okay. From Thomas Kaminsky to our work to Lion and to Takaaki Matsumoto, we showed the tornadic influence of the structures. I reconstructed this from his videos that were not known to exist before I went there last year, and that he graciously allowed us to capture, and I will be capturing in higher fidelity when I go there in the next couple of months at some point. And I will be meeting with the family again and being able to share updates. This particular connection with this central rod of the Caduceus going into the center, this hole in the overall ball lightning-like structure, is a key feature, and these offset structures, same as we observed copper here. This is infused quartz, and this is Dr. Alexander Parkhomov on boron nitride. This is, in my view, the tornadic influence on material, this being the second hardest material known to man. And here is the tornadic structure of a blown up structure that came out of the cavitation device of Dr. Roy Shinamaza when we did test. This is indium with these synthesized elements here. And they have at their core a iron-rich crenellated sphere. This was in a simple ultra experiment. These are the elements, the typical elements you see: magnesium, aluminium, silicon, and so forth. And in the Vega Valley, we saw how the micro ball lightning are instantaneously able to churn with an extremely tight fall-off brass. And when they blow up, they have the very, very key signatures with these material orbiting around the core. And in a separate video, you can go and have a look at this video at bit.ly/vv-twisterbl. You can go and see when this particular image was captured, with the Caduceus coming up to the hook, which is the same radius as the core of the ball lightning. And this is the material that was all part of the apple that would have been surrounding this particular structure. And it has a hole, and so very, very similar to a tornadic vortex. And I'm arguing that these go into the center of these structures. They capture self-similar structures that aggregate into and towards the phase singularity, and it captures material like this, like a tornado. Here is another one. This is on DHX2, separate reactor, VCS5RT, another blown up structure, possibly an iron-rich ball coming out here. This is captured material at the base of the tornadic structure, and you can see the vorticity here coming in to the broken up phosphorus containing structure. And we saw these lines similar in the impact mark of the thunderstorm generator, the 24-inch internal sphere of Malcolm Bendel's thunderstorm generator. The initial impact mark, that we looked at this area in 3D, and we saw that just like in a normal tornado, this area is more stripped, and this has got some deposited material left on it. The same is true here, and the same is true here. I will do another short video and add it to the blog for this up here. And that's because of the way these structures interact with various parts of the system. We looked at the mark of natural tornadoes, the hard line on one side, the direction movement here, the fact that the center line has less damage to structures, and the curvature here. I spoke about this, but I didn't get the video, so it's okay. Hard line here, and we explored that with the PDF here of the Moravian tornado by these chaps. Thank you guys. And some key structures here were the backflow with the deposit and the forward flow with the extreme damage, as you see here on the impact mark of the ball lightning structure on the inside of the Malcolm Bendel thunderstorm generator. And there was a couple of examples of the extreme fall off in this system. For me, I think my favorite possibly is the solar panels. Obviously, it's sad for those people that lost the solar panels, but here it's a very, very clear swathe cut through there. Okay. And then I had my little bit of crazy, and we looked at the spheres again. I talked about things going in and coming out, and the fact that these were the same self-similar objects caught in there. And I said, well, if you could consider this whole thing as, I've already described how these structures are effectively like little galaxies. They behave like little galaxies with their little black hole at the center, 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 so forth. What actually a black hole is in my view, a phase singularity. And this is the phase singularity, a much bigger structure. And therefore, you effectively have galaxies in a little bundle inside what is called a universe. And that if we use the rule of as above, so below, and replace the galaxy with a universe, you have a multiverse. And since we know that most of the matter in our universe is left chirality, and we call that matter, and we know we can synthesize antimatter, and that is right chirality, then it could be the case, since the universe is yin and yang, that there is a complete antimatter universe, which is essentially the same as ours, and I'm calling it the mirrorverse, where it's made of it's anti-galaxies, made of antimatter, and the type of matter that destroys things in our universe, or breaks it up, or literally unwinds it and converts it into raw energy, is right rotation, antimatter. And in the mirrorverse, it has almost a total lack of a left rotation matter, and left rotation matter for the mirrorverse would convert the matter in the mirrorverse to raw energy. Okay, and these effectively are topological monopoles that exist as a yin-yang pair, and that these again would be in little bubbles throughout space-time on different scales at different constants of gravity and distances and constants of light and time and stuff. And then I showed, as a little less crazy, that the yin and yang structures that make up these two little structures kind of thing, these are absolutely and categorically caused by the fractal toroidal moment, and you only need to look at the paper that I shared from 2014 from the American Physical Society quite a few years ago now, in an Assisi presentation on cavitation and axial hypertoroidal moment or fractal toroidal moment leads to, in their case, a ferroelectric nanotorus, left chirality and right chirality, two stable states, which can be switched between, which is something that is interesting to consider for controlling these things. But then when you look at that compared to this, it would appear that the levels, if this is true, then I haven't totally thought this through, I'm clear about that, but the kind of levels of volts that would be implied in differential between these two would lead to not only the splitting water, but the splitting of the hydrogen bond, which means there could be a particular quanta scale of these things that leads to a state where they can self-feed themselves and keep the process going. Because if they're able to use the oxygen from the water, that produces the magnetic structure, as we've shown with the SEM EDS analysis on Dr. Royston Mars' steel plate, and with the protons there going into the phase singularity and being unwound, they can provide raw energy for the process to go ahead and you know, do work on other matter. And so I speculate there is a specific scale at which the process starts to work on its own to a large degree, until these things become unstable and crash into things like tornadoes do. Like this one obviously did, and like some of these did when they died at the end of these channels, like this one obviously did in the VCS5RT, like this one on the right obviously did, and this one on the left obviously did. Lots of ways to die, lots of ways to die. We don't actually know if this plasmoid ever died, because it went off here and it kind of left the metal. We don't, well, we did see a sphere a bit further on, but we don't know whether it died. But anyway, I commend to you Ode Tornado. Thank you very much for your time, and I will see you in the next video.